Okay, guys, starting the stream a bit later today. Sorry about that. Had to wrap up a couple of other tasks before starting the stream, but now we are live and going strong until midnight. The filtering pipeline has done processing during the night, so we can finally head over to data preparing stage, and that's gonna be the topic of this stream. Let me just open the live chat. Let me post as usually, the live link to the Discord server. Okay. Streaming right now. Okay. Let's go. Let's see where we stopped. We want to now go through the data preparation phase. Let me find the data, prepare data scripts. Okay, we have prepare configs, which we need to run now. That is going to prepare the necessary config for the prepare data YAML, and then we'll be able to run the prepare data script. Welcome everyone to the stream. Let's kick off this script here. Let me see whether I have all of the paths correctly set up. So we are going to grab the train primary, and the filter data root path is the filter out. Let's just see whether that pipeline's filtering filter out. Let me find that directory. Here it is. All of the batches are over. We have the data inside of these train primary directories. So let's run this. Okay, and then open, and then just dump the train corpora. That's it. Let's see how it looks like. Here it is. So for different directions and for different data sets, we finally have the filtered data inside there. One thing that might be valuable to do before we head on over to data preparation stage is to just count the number of lines we have in these files and contrast that to the original data, just to get a feeling for how much we've filtered out, so as to potentially prevent some errors from creeping in. Let me see. One weird thing here is I don't see multiple. I think we have a bug here. I don't see multiple data sets per language direction, or do I? No, I see it. Okay, here it is. So for language direction, we might have more data sets. For English to this one, we have a ton of different data sets. Okay, this is looking good so far. And then here we just have to link it, and we did. So train prepare data train corpora YAML, looking good. Output directory is going to be process data, and we went through this already before, so we're going to just kick it off. But before that, as I said, let's first analyze the data. Let us go to the analyze script in fairsec. Okay. This is from last night, actually, the mined data script. Let me just quickly see what this is, and then we can head over to analyze the filter data. Let me just see whether this will work. Generating train split, total shards. Okay. And for some reason we are hitting an error here. Bad splits. Expected. Recorded. There is some discrepancy that's going on in here that I'll have to debug later on once we get to mine data. For now, let me stop this and let's go to the analyze script. Examples, NLLB data, analyze data script. Analyze primary data. That's something we already have. Now let's analyze the filtered primary data. The logic will likely be very similar. We just need to change the paths, and we need to read from gzip as opposed to raw files. Okay. Let's see. Let me just first quickly kill VS Code because linter is dead. Let me reopen the window. Open recent fairsec. Okay. Okay, linting is alive again. We need to modify this now to analyze the filtered data. Let's see what's the path. Filter out. Let's copy the path here to the filter data. Okay. Okay, now Judd. Sorry for being a bit late today. Had a couple of tasks to wrap up, but we are back. Okay. We're trying to now iterate through the filtering output of the filtering stage and analyze the sum of the statistics, like number of lines for each of the languages, and then we can contrast that with the numbers from analyzing the raw primary data. So I'm going to rename this to analyze. This is analyze raw primary data. And we want to additionally analyze filter data. Let me quickly see the assumptions I made here. So we grab the files, we count the number of total files, and then we go through the directory of the raw data. We pick up the files and we count the lines. And then we do the same thing for directions, and then we plot. So let's maybe try and see what happens if we just pass in this path instead. It might actually work. Let me put a, let's modify the JSON here for analyze the data. Filter out. Let's comment out this one. Okay. And let's now run the analyze data. Although I suppose this one will fail because this is not supporting gzip suffix. Let me see. Let's see what's the format of the file there in Stokes. So here, if we open up this one, okay, the code is actually just before the suffix, the gz suffix. So let's handle that. Let's maybe make this one capable of retrieving also such files. Okay, let's add a flag here. This is gonna be set to false, but if it's set to true, actually this should be the other way around. So if it's actually gzip, then we want to grab the second penultimate one. Otherwise we grab the last one. So this should now work if we just pass in the flag. Let's go back here. Let's pass in the a new. We actually want a Boolean string, a Boolean flag. Let us see whether any of these is already using it, so I can just copy paste. This is fairsec. Let me quickly open up one of these files, just trying to get the flag so I don't have to Google. I don't remember the syntax, so let's just see. Prepare data maybe. Okay, it doesn't matter. Let me just Google this. Okay, let's reopen fairsec. Let's go to analyze. We want something like this. Okay, and then we passed to all of these ones. We passed the flag. Okay. Looking good. Now we just need to modify this one and pass in the flag. Maybe EaseGZ is not the most intuitive flag, but let's just test this and see whether it works or not. Hi Smith, welcome. Whoops. I made some mistake here. What happened? I guess I picked the wrong. Analyze data is the right config. Okay, let's now rerun this. This is set to true. Let's see whether this will actually work. Okay, root train primary, still nothing. And now finally, here we should have the files. Here are the gzip files. We grab and we don't get anything. Interesting. Why not? Huh. Let's just step into this function. Let's step into it. If it's a file, okay. We need to pass in a full path. I'm not sure how this even worked before. Just a second. So files. Why is this? Huh. Why did this ever work? We need to remove this here for this to actually work. I think this was a mini optimization I made yesterday, and it seems I introduced a bug. I'm not that familiar. I haven't been training anything significant with deep speed so far. I've been analyzing the code base every now and then, but like not really an expert. Okay, let's see whether this will work. And moment of truth is here. This should now work, I think. So we grab the language suffix. It's good, so we basically append it. Okay, let's exit. Let's see what we got. And we got the 2 gzip files. Awesome. Okay, let's see the number of files. 722. Okay, let's stop there. And let's rerun with just your regular, with our regular raw text arguments. And let's see whether this gives us the same number. 722 is the number we're looking for. Okay, let's rerun the analyzed data. And let's see what we get. $722. Awesome. So far, so good. Let me kick off this counting of lines for each of these 722 files, and let's see what do we get. Found 94 languages. And here are the actual numbers. So let's store those numbers. Let's store those numbers somewhere. Well, you use debugger logger never works. Is there any setting or config? I'm not sure how logging is not working. Are you using print or how are you logging? Let's see. This is not going to just compute everything the same, but just for... Okay, let me save this. This is a dictionary. So let's just pickle it. Let's quickly pickle that dictionary. Let's import pickle. And let's dump it. Okay. And then let's just save the actual dictionary. And that's it. Okay, so quickly, so that we don't have to rerun this, or let's just rerun this. Let's just rerun this with the raw arguments, with the raw text. Not print, logging. Well, the reason it doesn't work, you probably just don't see it. You need to figure out where the logger is actually outputting its results. Maybe it's a file somewhere in your file system. Depends on how you set it up. Okay, where is this saved? Here. Fair enough. Let's now go and rerun this with this. Let's save it. Let's stop this. And let's try and rerun. Do we get the same statistics? How many languages did we have before? Was it 90 something? Well, we'll see soon. So number of files we found, 722, that's fine. Now let's see whether this will actually work. Whether the counting line works for this file. Oh, it actually works, nice. Nice, because count lines is basically going to open file name. We pass in the file name here. If it ends with gzip, then we basically use zcat instead of cat. And that will just work. Amazing. This handles gzip files as well, out of the box. So let's just continue doing this. It's a bit slower. It's counting the lines. Super curious to see what's filtering, what percentage of the data we lost by filtering. Okay. While this is running, let me check something. I just made a tweet about our project. There's been more and more engagement over the previous past days. A lot of you guys wanted to contribute. If some of you if you're here for the first time, check out the Meta NLLB replication channel. That's where we collaborate. We have a ton of people now who are starting to run this, set up the environment. We're helping each other. So join here to get help if you want to contribute. Even if you just want to help around your native language, that's fine. You don't have to do any super technical stuff if you don't want to. Okay, let's see how many files. We should find around 94. I think that's the same number. Okay, so now in order not to overwrite this, let us just import pickle here directly in the debug console, and then let me run this, and let me call this filtered, and then pickle dump. So we dump that same dictionary, and this should now work. Here it is. We have both of these saved. I'm gonna stop this now. And let's quickly analyze it. Let's quickly analyze this. Analyze dumps. Let me just create this function quickly. So let's load this one. whoops, first path is gonna be this, and then the second path is gonna be this. And then we just need to load the pickle. Load pickle 1. And then repeat this for the second one. Okay, and now we want to iterate, or we want to plot. Let me see what's the best thing to do here. Maybe we can plot the data, but it's not gonna be really visible. Let me see. Let's try. Let's just do the following. Let's try and log this like this. So we pass in log values 1, log values 2. Why is plot not getting recognized? Not sure. And then we want to repeat this for dictionary 2 keys and log 2 values, ideally with a different color. And that's it. We need to import here so that we can reuse it. Okay, let's try and run this, guys. Let's see what we get. Run. Load the first pickle. Load the second pickle. These are now dictionaries. 94, 94. And we grab the values. We plot the first one. We get something here. And then we plot the second one. And we, of course, lose the initial data. Because can we... Let me just see for a second. What's the filtered pickle is pickle 1, which will have less data. So let us change. The first path should be raw. This should be P1. This should be P2. Let's now rerun this and see whether we'll have the smaller bars being red and in front of the blue bars. Okay, I hate when it doesn't block and instead it just remains there. Rerun. Here's the first bar. Here's the second bar. I guess it's hard to see on the log plot, but we did lose some data. Okay, that's the result there. Let's try and maybe be a bit more numerical. Let's see, maybe we can compute the relative percentage of data we lost instead of going the plot route, which is not really, or we can ignore the log. Let's remove logs for a second. If we do this, maybe we can see the differences a bit better. Let's rerun. Again, for those of you who just joined, basically just trying to visualize the amount of data we lost during the filtering stage. So yeah, obviously this is when it's not a log plot, it looks wild. Let's run this one. And let's see the results once this unglitches. Okay. so we can see a bit better what happened. Not a lot of data was filtered out. So let's go through the values. And print the difference, and also print V1 being the original. Let me just think, what do we want to do here? So V1 is the filtered, no, V1 is the raw data, V2 is the filter data. If we do something like this, then we will see we just think what we want to plot here to print. How much of the data was lost, relatively speaking? Okay. And then we can multiply that by 100. Okay. And let's also print the keys. Which contains the language. Okay, just pretty printing it. Why did this open? Let me close the GitHub Copilot tab. Every now and then I accidentally open this tab. Not sure why. And then VS Code just dies. Ubuntu and VS Code are a terrible combination. That's what I noticed. Compared to Windows, the experience is subpar, to say the least. Please, just stop. Cancel. Okay. Let's go. We only have 94 languages, so we can quickly go through this and see what's going on. So for Chinese, we lost 66,000 lines. Interesting, which is 66% of the original data. Oh no, this is the amount of data we keep, right? Because we see once we subtract V2. Wait, this is weird. Just a second. Why would this be the case? Is this the amount of line we are left with in English, or the amount of line we removed? Should be the latter. Wait guys, I have some bugs. Something weird is going on here. Trying to... Hey, Asmonix, welcome man. What we doing now, boss? We are analyzing the filter data. Is the mic good? Is the sound okay? I'm just using Rode NTG mic, directional, so hopefully you don't hear too much noise. It's good but quiet. Okay. Interesting. This is the second person that said that, but then other folks usually did not complain about the sound. Can anybody else confirm whether the sound is okay? Until then, let me see what happened here. So we saved the filter data. Let's rerun this. It could very well be the fact that because these are dictionaries, we are not comparing apple to apple because it's not sorted keys. Let's just double check one thing. Let's go through the let's do something like this instead. Comment out this. Just go through the dictionary. Grab the value 1 by grabbing this and value 2 like this, and then this should now work. And we don't need the plots here. So this is fine. Smith or anyone else on the stream, can you guys confirm you can hear me well? Okay, here's the value 1, here's the value 2. We print. So this means we lost what? We lost 1.3% of data for Chinese. 1,317 sentences have been filtered out. 2.76% for English is lost. 2.59, 1.74, 1.4, 6.25 for MAL, 15.99 for Hindi. Interesting. Fairly aggressive filtering for Hindi. Okay, a good thing would be to now plot these values. Let's create relative values and just populate the array with the numbers above, and then we can actually create a bar plot again. This time we don't need the log or anything. We can just put in the relative values, and we don't even need the keys. Or actually, let's just put in the names of the languages like this. And let us rerun and see the results on a plot. Okay. So some languages have lost a ton of data for some reason, which is not a good sign. This is why I'm doing these analyses in the first place, just to catch any potential issues. So apparently Spanish lost a ton of data. Let's just double check we are not messing up the labels. So dictionary 1, Spanish. Dictionary 2, Spanish. So this is indeed what what's the number we get? 38%. And for me, the sound is okay. Awesome. Thank you, Nevena. So Spanish is indeed 38%. Let's see this other language called GRN. GRN, what language is that? Can it be Grusian or some Georgian, or no? That's actually, I'm messing up. I'm mixing some Serbian words with English. Let me just see. What's the GRN language? Let's check out the ISO codes. GRN is Guarani. Okay, let's see for Guarani what's going on. GRN, and then this one. Okay, so we lost literally 50% of the data for Guarani. That's why this analysis is important. After every stage, visualize the data. So we started by literally visualizing the number of sentences. Then we ran the filtering pipeline. It took a while to run it on my machine, and now we see the results. Again, let me show you the plot. The biggest hit we get is for Guarani and Spanish. For French, we also lose around 20% of the data for some reason. And then there is this language, ORY, FON. I think those are some low resource languages. And we definitely don't want to be aggressive in filtering those. So this might need some additional refinement, our filtering stage. Let me check in this code, and then we can continue to the prepare data pipeline. If that makes sense. So I want to check in some of these changes. Is for output of the filtering stage. Okay. So the good thing is we can reuse the same function here for both raw text as well as for gzipped text from the filtering stage. And then we can analyze the dumps by just opening. We don't even need to do this. We can just do something like this. And also here, pass in the file name directly. Okay, we print the values, we append, and we plot, and that's it. Analyze the dumps. So we can leave this as it is. No arguments for this function. Okay. Git status. No, we're actually here in a wrong path. Let me just open up one of the terminals that is in FairSec. Just a second, I have a ton of terminals opened up. Stopes, FairSec. Okay, let's see the changes we made. Analyze data, language code mappings, those have changed. train script. Okay, let's see. Let's just do diff tool and see what are the changes I made here. Okay, analyze data. Okay, looking good. This one, ISO mappings. I removed this file line, which was causing some issues. Okay, this makes sense. And then we can ignore the YAML files. Let's just see what's the change in the train script. Okay, I just changed the number of CPUs per task, which is hard-coded, which is not a good thing, but we're just reusing the stuff from FairSec. Okay, let's add this change as well. Train script, and everything else here is just data, so we will not be submitting that. I should probably add some git ignores here. By the way, if anyone has a solution for Ubuntu for how not to have to input this information every single time, that would be helpful. Okay. That's it. Let me just notify people there was a small bug here. Okay. Let's go to prepare data. We need to open up Stopes for that. Stopes repo, prepare data. Let's see the config, filtering, populate. I don't think we have to specify anything. We just need to take the no-r config here for prepare data, because everything is basically already stored inside of the config. So let's kick this off. No-r config, let's kick it off. Okay, so we grab the path, we load the information. Here it is. And then we store that directly into config. We call the prepare data. This is going to create the output file is going to be where? Let me just see that. Output is going to be prepare data, process data. So here it is. Here's where the output of the stage is going to be dumped to. Let's go back to the line here. Let's continue. Create a launcher. Get the data sets. Okay. So we are iterating and grabbing the gzip locations, and then meta is going to be always empty, and that's it. So we can hit F5 here. We get how many data sets 361. Okay. Let's continue. Check files exist. We just dump the config and we can now run the pipeline. Let's hit F5 and let's start here. So the first one is just going to validate that all of the lines match. So the source and target ones match. Let's see how long this takes. We do have 30 gigabytes of data to run with. So this might not be as fast as I would like to. Let's just enter the validate stage and see how it's progressing. So it's running this validate data run, and it's counting the number of lines. Let me just see. Data sets. Iteration value. Okay, it's outputting some stuff. Bunch of timeouts. Okay, might be better to batch this the same way we batched the filtering stage. So instead of passing 360 datasets here into this config and then calling the validate data, this is being run in parallel by the executor. Maybe we can somehow modify the executor so that we support batching. Let's see that quickly. So launcher is local. Max job array jobs. I think this is, maybe this might be the number we have to lower down to like 10 or something so that we are not hitting these issues. Let's see where this argument is called. Launcher. Okay, so I think that, yeah, that's probably the logic it's using. It's just patching using max job array argument. And then it submits all of those jobs. Let's put a breakpoint here for the next time. Let me stop this. Let me stop the whole run. Let's clean the filter output. Oops, not this one. Actually, we are looking for the data output, process data, this one. Let's just clean all of this. And let's rerun this, but change the setting. Looking for the launcher, local. Let's go and put this to maybe 15. And let's kick it off again. Hopefully we hit this point here, and in that case I mean, that's the only place where we call this argument, so it must be here. It must be here. Okay, let's start again. Let's go to the prepare data. And let's kick it off. F5. Okay, let's enter the validate. Okay, and then schedule. We'll hopefully hit the line there now. Okay, here we are. This is set to 15. We have a ton of tasks to submit. 361 tasks. So let's first grab the first batch. Okay, I did interpret that correctly. The setting is indeed we are going to submit now. Let's hit F5, and now this is going to trigger 15 jobs only. Now the issue is this is not a blocking call apparently. So it seems we can again go F10 and then enter the batch context. We definitely need to get some compute. I might reach out even now on the stream. I might reach out to stability or some of the options we have. If you take a look at our project document here, we have multiple options we can pursue. Andreessen Horowitz also recently started offering AI grants. Stability AI, a couple of these projects. Chris Ha from Eluther AI told us about these. There is Lion as well. Okay, I made a mistake here. We don't need the checkpoint here. Let me just, again, I'll have to stop this stupid error. So this cannot be obviously breakpointed. We have to put the breakpoint only here and kick it off. I'm struggling with these many files. Prepare data. Okay. Let's run this again. Validate. Okay, here we are. First batch. Submitted. Okay. It's running, as you can see here on the left. Okay, slowly completing. Almost done. Almost done. All of those succeeded. And that's it. So we can either manually do this. Let me hit F5 again. The issue is there is 36 steps here because we have 360 jobs, validation jobs. Should I just let it run? Will it then keep on submitting? What's stopping it from running more jobs? That's my question, I guess. What is the thing that's stopping it from running too many jobs in parallel? Max job arrays. Will this keep, is this smart enough to always keep at 15? Let's just hit F5 and see what happens. Okay. It looks like it's smart enough to always be scheduling jobs as they go away. Okay, that's good. That's good. Hey, Mohammed. Yes, we are targeting 202 languages from the NLLB project. Let me see, which language do you speak? Which language do people speak in Somalia? Oromo. Do you speak Oromo or something? We are literally looking for people who, you speak Somali. Okay, so that's a language itself. Let's see, Somali. That one, we don't have anyone for Somali. That would be amazing, man. Let me see. So we have this list of language champions. You can add your name here if you wish. We don't have anybody covering Somali at this point. You want me to put you here? And are you already part of the server? Join the server here and join the Meta NLLB replication channel. That's where we are synchronizing on all of the work we are doing related to this project. We also have a bunch of pin posts here. You can see the project document, tasks, everything else. What are the tasks? There is no hard expectation. You'll just be like, ideally you'd go through some of the data that has Somali translations and see whether there are any serious issues. For example, it's not a Somali language, the label is completely off or something like that. That would be the task. No worries. Awesome. So yeah, it's there are no obligations. Only if you wish to contribute to the project, you can put your name here. Later, all of the people who contributed, we'll take this list and we'll put some of these people who contributed. I mean, all of the people who contributed to the README, to the credits section. So like a shout out for your work, and people can notice you. So I guess that's the perk. Okay, again here it seems. It's not smart enough to keep the number of processes always at a certain low number. Instead, it's constantly running a ton of processes. I'm not sure why. How do I set that? How do I control the number of parallel jobs. Let me quickly analyze the settings and see whether I'm missing something. Prepare data YAML, partition, cache, output, sharding, dedupe, vocab, preprocessing, launcher. Launcher can be the only thing that makes sense. And stop score launcher. Okay. Let's see whether they mention parallel. Nope. The good thing is none of the jobs is failing so far. Again, trying to understand why it is running more than 15 jobs when I specify that in config. Here's the launcher class. Cache, config, log, cluster, partition. Okay, it seems we are almost done. Did we already enter here? Let's see. I don't see any setting other than this one that can control the number of parallel jobs. Max retries, dump config. Schedule. Get executor. Requirements. Let's check this one. Let's see what requirements it's using. Maybe it has too many processes set as a requirement, and thus it's running just a ton of the processes as a consequence, thinking we have more processors than we actually have. That's one assumption. Update parameters. Schedule a single job. Submit the job. Schedule array. That's the logic we've been. Schedule multiple jobs at once. Okay. Why are we not making any progress? Where is this stuck? Where is the execution stuck at? I'm not sure. Drag job, that's it. Like, this is the whole logic. So I guess we need to enter this function here and understand what's going on. Can we force the execution to stop and show me the breakpoint in VS Code to show me where it is? All of that is just manual breakpoint setting. Let's see. How can I pause my code? Okay, this article might contain some answers. Okay, not really useful. I have no idea where we stand with validation. Retrieve data is empty, so that means we can still be, we are not yet at the second component of the pipeline. We're still stuck in the validate for some reason. Good morning, SQ. Welcome. Welcome back. Yes, filtering done. We are going through preparing data pipeline, but we are stuck in the validate component for some reason. I can't figure out where my execution is at. If I just stop it here, I'm not sure what happens. Where is it? Where did it stop? It's trying to acquire waiting. Block until the internal flag is true. It might just be blocked erroneously in threading. Something's not all right. Okay, worst case, we can skip the validation component and just assume everything looks okay. Let's just stop this. I can't wait. I'm not sure what's going on. That's why you need breakpoints, to understand where you are in execution. Otherwise, sometimes weird glitches. Okay, let's disable all of the breakpoints other than this one. I want to step into the batch. I want to understand what's going on here. Let's go to prepare data. Kick off the run again and see what happens once we hit the breakpoint and enter the batch script, the batch function. Okay, this time, why is this running without me? Look at this. Why is this at 50% all of a sudden? It's probably caching. Okay, it did cache some stuff. Let me see if we go to prepare data, filter out, process data, cache. It probably cached a ton of different things. Interesting. Let's go. Let's grab a batch of tasks, and then what does this do exactly? Context lib. Okay, enter. Executor. Okay, submitted core batch. Allow implicit submissions. Creates a context within which all submissions are packed into a job array. By default, the array submissions happen when leaving the context. Okay. Yield none. Submit delayed batch. $15 jobs. 15 submissions. Timeout in minutes. Executor logs. Pickle path. Set the timeout. Dump. Throttle. Okay. Submit. Using the pickle there. Here's the job. And then append the job. Okay, and then and then we promote them, whatever that means. Pop update class. Let's exit this. Return false. Okay. So what is going on now? Okay, these are just running now in the background. Why don't I see the progress once I hit F5? Weird. Let's go to submitted. Repo and see whether people are experiencing any parallelization issues. It's an open source project, if I recall correctly. It should be open source, MIT. Okay. Are we done? These jobs are now running in the background, not cached. 182. Already cached, 179. Found 179 already cached array results. 182 left to compute. Submitted array for, okay, and then for task. Track job. Here's the job ID, the state. Get total jobs count. What's this number gonna retrieve us? 0. Okay. We shouldn't have to do this, but that's life. Module calling the parenting Stopes jobs. Register the job. Okay. Let's hit F5. Tracking the jobs. They are running in the background apparently. They are taking too much time to complete though. Not really clear what's going on. Array parallelism on a local machine. Okay, I need to limit the number of jobs running in parallel. I tried with update parameters array parallelism 1, but they don't do anything. All my 500 jobs start in parallel and my laptop freezes. Solved here as suggested. I had to add update parameters tasks per node. Okay, let's see what do we have set as task per node. Only 1. So what might be happening is that literally we submit all of these jobs, but They're running, but only a single one is executing. Okay. Okay, we are apparently setting that one to 1. So we are definitely running this prepare data, out data. We definitely have this set to 1. And all throughout the code base, it's always hard coded to 1 exactly. CPUs per task. We might need to change some of these settings. Okay, here it is. It's wrapping up. Will we hit any breakpoints? Let's see. Or we'll get stuck again. Executor. Okay. Let's put 16 here. For later, this is filtering, so it doesn't matter, but let's just make sure we are maxing out the capacity. Might not match your setup exactly, but I believe that when using the submitted local launcher, tasks per node might be what you need. That worked, thanks. Okay. Check out, expand the discover the local launcher parameters. That's here. Let me just see. Installation, usage. Local launcher. CPUs, GPUs, tasks per node. Check out the config file. Number of tasks to spawn on each node. Is there any better explanations? Tasks per node does not keep the number of tasks to 1 for the local executor. Exactly, that's what I'm seeing. I use the executor batch to perform a delayed batch, which then spawns a process for each job, which quickly overwhelms my computer. The issue seems to be that a controller process is spawned per job. Okay. If you start 100 jobs using local executor, they will run at once without regard for the hardware requested or hardware available on your machine. Ensure we haven't implemented a queue for local executor. This is a major foot gun, but also not something easily fixable. We'll need to think about it, how to implement this. For example, I feel we would like to spawn the subprocess ASAP to be able to return a process ID which serves as job ID, but make sure the jobs actually start one after the other. I personally often use the debug executor, which will run exactly one job at once. Okay. Okay, this was never solved. Well, at least we know that I'm not crazy. Again, this is just running and who knows what happens. There is an alternative. I do have Slurm enabled on my Ubuntu machine, so I can run Slurm jobs, but I'm not sure. We need to debug something. You seem to be using submitted correctly. Okay. Okay, so we have issues with local executor. Let's again pause this. Let's stop this. And let's rerun. Let's see whether, again, we probably cached a bit more of the files now. Let's see, maybe that's an option. We can just rerun stuff a couple of times. Prepare data again. Let's kick it off. And let's see what we get now. F5. Okay, requirements. CPUs per task. Why is this set to only 1? Let's try and set this to 16. But let me see where this comes from. Module, get executor, module, schedule array, module, somebody calls schedule validation module, Okay, so this guy has requirements set to, okay, let's put this to 16. And let's rerun. Okay, let's see now. Set to 16 exactly. Hit F5. Okay, let's see whether we pass 50 from the previous run. We do 60, 73, 87, 93. Okay, it seems every time we run, some of the jobs finish, and then let's hit F5. Some of the jobs finish, but some of them get stuck or something happens. We're using 16 CPUs. Now let me just see whether, oops, something actually happened. 94, we are progressing. Okay, 95, nice. Maybe the bottleneck was that I'm using a single CPU. Let's see. System monitor. Well, it's kind of hard to estimate looking at these plots what's the actual utilization by these processes on my CPUs. And also apparently I have 32, probably some virtualization going on there. Okay, here we are. Oh, nice. Guys, we are now in the, we exited, we completed everything. So, the only issue is, why do we only have 52 here? $82 here. 277 here. Okay. I want to restart this with 16 CPUs and see whether this solved the issue, because we'll be running this. My goal now is to just get a decent understanding of all different parts of the pipeline and get it running end to end, and then we can start optimizing stuff. But let me see if I grab the process data, if I rename this to 2, so we save that. But now let's rerun the prepare data and see with 16 CPUs what's the progress we're making. So it will have to start from scratch now, but it's gonna run on 16 CPUs. So we should be seeing some progress. Okay, let's see, process data. Here's a new directory. We are running. It's a shit ton of Python processes running. What's this? How can I parse this? So I guess that's the 300 processes we're trying to run. Something is going on. So what's the status? Maybe the additional issue is that I'm running it in a debugger instead of just kicking off a run. Would be cool to try Slurm. Okay, let's see how we can set up Slurm. Well, this is running in the background on hopefully 16 CPUs. I'm not sure whether it's obeying the commands. We already see that it's not obeying the number of tasks per node command. So let's see. Prepare data, submitted. Partition. Dragon, that's the name of my partition. Max number of jobs, let's say again, maybe 16 jobs. Because that's the amount of CPUs I have. Of course, I mean, so let's see. Instead of local, we can set it to submitted. And we can kick it off. This seems to be reducing the amount of these jobs. So let's maybe wait a couple more minutes. And then we can also test with Slurm and see how that's going on. We should have more control over Slurm than over these local launchers, apparently. What's the final step before being able to make visualizations of data? We can immediately visualize, for example, number of sentences after you downloaded the data. Check out the analyze data by script. Okay, Stopes seems to have gotten to this stage where it's again stuck. Let's stop it and let's rerun, see what's the progress here. How many files did we cache? Let's see where we go over 50. The last time we went to 50 with one CPU. Okay, only 39. Interesting. And then there are all of these jobs being submitted. Okay. But they're stuck. Weird experience there. Analyze data. Yeah, that's the right name of the script. Let me just share some of the plot with them while we're waiting for Stopes to finish. Let's go to analyze data. Let's rerun this. We can ignore this function. Let's just run the analyze dumps. Boom. Figure 1. Data that was filtered out per language. Some outliers like Spanish. Maybe we can check the paper as well to see what's the expectation there. Let's check the paper. It's okay. This is definitely stuck. Something's not okay with. Let's disable all the breakpoints in case it's hitting something other than this one, and then hit run again while we're checking out the paper. Is there any filtering section? Let me just see. Filtering. There is no mention of filtering in the Table of content. If somebody can find this in the paper, that would be super cool, guys. Maybe open up the PDF and try. If you want to help a bit, that would be amazing. Let's try and understand the amount of filtered out data for them when they're on the filtering stage. Laser filtering. This was the filtering section here. Data set, filtering. They have the performance. Preparing the model. Curriculum learning. Comparison on floors. This is just evaluations, performance, toxicity. Distillation. Again, just performance, environmental impact. Okay, let's go to appendix section. Maybe they have some charts there. So, LID results. Ablation. Not the thing we're looking for. Main data sets to train. Okay, nothing there. Candidate toxicity. Scores. Nothing in the appendix as well. What's going on here? This guy is stuck every time. This is not good. Let's just test it on Slurm. No, wait. I think now we're actually running on Slurm now, right? Because I've set. Let me just retrieve back. Let me go here. Let me prepare data local. So we might have issues with Slurm as well. Let me just see. SQ. Oh my god, there is a ton of requested node not available. Let's just cancel all of them. Can I cancel everything? Can I cancel all jobs on Slurm? Slurm cancel all jobs. You can run okay. Cancel for username Aleksa. That's it. Now that that's gone and this is set to local, Let's rerun, prepare data. Okay. Let it run in the background while we are chasing to find some insights in the paper. Languages. This is just the quality of Flores 200 eval dataset. High-level diagrams. Qualitative stuff again. LID scores. Confusion matrix. Effect of sentence length on performance. This is just LID stuff. Okay, key stuff. Clean sentences. Here are some numbers. Here are some numbers for monolingual data for high resource and low resource. For high resource, we can see that they lost over 50% of data, clean sentences. Here, they somehow gained data. There is more clean sentences than raw data, but these are paragraphs, so maybe there's, I'm not sure what their definition is, but definitely very much confusing. And this is also monolingual, so might be worth looking into analyzing those particular directions, and so that would be a good task. Figure out why are we filtering out that many sentences for example, Spanish. Is it hitting the length filter, or we have too many duplicate pairs? Those are the filters we are currently using. Let me open up this. Maybe we can start adding these to Discord. Let me just do GitHub, sorry. Let me go here. Pull requests. Where are the issues? Okay. We can easily translate this later to GitHub if we need. Let me just for now note it down. Guarani. Guarani. I think we have a person for Guarani. No, we don't. We have for Gujarati. Somali. Oh dear. We're slowly getting more and more people here. Awesome. Okay. Let's see what's going on here. Prepare data. Let's rerun. See whether we are getting more cached files being processed. It was 39 the last time. Now we are at 74, 77. Okay, so it seems that no matter how many CPUs we use, it still takes a couple of reruns to push through the component, which sucks. 78. Now we're seeing some progress. Let's try and fix Slurm after this one, and then we can transition to handle the rest of the components in the pipeline. The next one will be retrieve data. I'm just thinking about various different visualization techniques and stuff we can do. For raw data, we need to see the number of sentences, the number of languages, directions. Then we filter out, and we need to make sure that we did not filter out any directions, any languages. There are no issues there. And then we need to visualize the number of sentences and analyze why are we filtering out certain languages more than the others. Understand those specifics. We also need to check whether in the initial phase where we restructure the data sets after the download, whether there are any bugs there. So there's a ton of tasks I already see as we are progressing through the pipeline. And then there is also, we have to integrate the mine data sets, the mined by text, into the pipeline. So there is a ton of work to be done, but we are now pushing through the pipeline just to get everything set up, and then we can slowly distribute tasks and attack one of these at a time. Guys, if you're still listening this, let me know if you're happy to help with any of these data analysis tasks. If anybody wants to grab this one and understand why are we hitting, why do we have these outliers? If you want to do that, I'm happy to point you to certain directions on how you can reconstruct this and try and analyze it yourself. 96, 97, awesome. We are progressing here, almost done, almost done. 99, okay, here we are, almost done. Great. 52, 82, 277. These are the number of sentences for each of these languages, okay? So for some of them, as you can see, we only have around a couple of thousand sentences, which will not be enough. But don't forget, we don't have mine data yet, so we're good. Are you using the correct encoding? I have no idea. We're using UTF-8, I think, everywhere, so I'm not completely sure. Let me just put another task. This is for myself, though. Let me just put the task here. So what we want to do is try out Slurm with validation component of the prepare data stage. Okay. Let's enter the retrieve data stage. Enable all of the breakpoints, hit F5. We are here. So we go through the data sets and we have 361 of them. And we just keep on adding the fold and the direction. $277 of these. Okay, so that means, so that's the 277 number from. So we have 361 of data sets, but we have 270 something per language direction, because oftentimes for a language direction we might have multiple data sets. So let's see. We now just construct the jobs here. Okay. Hit F5. Construct the... There is a ton of jobs, 277 jobs. And then schedule. CPU per tasks, we want to have 16 here. I'm not completely sure what it does though. Let's run this. Okay. Source target. Let's go ahead and just run one of these. Concatenate the files. How many data sets do we have? Is this one of those where we only have a single one? Yes. So concatenate data, let's just enter here. We analyzed this data yesterday, by the way, so when I say data, I mean this code path. So we zcat the output of this, and then we pass it through Perl to normalize. And we dump that to retrieve data. Okay, let's see. And we are back. We do the same thing here. We run it, and we're back. And we construct the data set. That's it. Save cache, and we hit the next one. Hit F5, remove this. Now the issue is I'll have to run all of these manually. Can I kick off in VS Code all of the processes at once? What would be the command for that in debugger? Continue, step into, step over, restart, stop. Can I just run everything? Let's see how this is progressing. Let's open up the process data, retrieve data. So here is where we stand at the moment. And we just keep on adding 2 at a time. 2 at a time. As you can see here, looking good. Looking good. We are preparing our data. Let's go. Let me hit F5. Let me keep on hitting F5 as fast as I can here. Okay. Let's see what's gonna happen. Let's go back to prepare data, and let's put a breakpoint just after the retrieve data sets there. Build vocab. Nice. It seems we are slowly populating this directory. Looking good. Arabic. I love the scripture of Arabic languages. It's a miracle language, I guess. There is something very elegant about it. Although the most pragmatic one definitely is the Latin. It's just so simple, a couple of characters. Additional cool thing to do would be to visualize the statistics of line lengths before we do line filtering. I guess that's going to be a part of the task of understanding why we're filtering out that many sentences for certain languages. That's something we can definitely do while we're waiting for this to finish. So it keeps on adding more and more. Amazing. Guys, I'm so hyped up about this project. It's just unbelievable. Even though I might not seem, because I'm working 10 plus hours a day, so I'm not that enthusiastic. I have to keep my energy to myself. Just super promising. How long did it take for you to transfer your first ever paper to code? I mean, it depends. There is a lot of variations, right? Sometimes you start with some code. It's rarely that you start completely from scratch. Sometimes I just combined multiple sources. I've been analyzing like multiple repos. All of them were bad and kind of working, and then you combine and rewrite something from scratch yourself, but still you do leverage other people's ideas. I don't think anyone takes a paper and then without internet connection reconstructs it. Is there a deadline for this project, and what is the big goal behind it? The big goal is to open source the 3.3 billion checkpoints so they can use it for commercial purposes. And we can maybe later create an API or something that people can use. Also, I would love to train large language models for non-English languages. That's why we went through the Arabic LLM paper, the JAIS, spelled JAIS, yesterday on the stream. So yeah, there is a lot of promising work there. Let's see how this is working. Is it still appending the files? While we're waiting, we can go and play with some visualizations while we're waiting for this to finish. Okay, so definitely let's go to filter. While we're waiting for this, let's go to the filtering stage. Filter. Example. So again, the types of filters we're using currently is deduplication filter and length filter, nothing else. So let's understand why are we, let's just create a function that's going to analyze a particular language and create a histogram of lengths, or just tell us about the range of lengths we can see in that language in general. So again, I'm going to do all of that in the analyze script. Let me quickly just see how the length filter works. Is it using the number of characters, I think, or whatnot? Let me just see the config, filter config, group filter config. Where is the length config? Here it is. Length filter. Let's find its class. Here's the length filter. So filtering of the line. Filter empty lines. What are the prerequisites for you to contribute? There are no prerequisites. As long as you think you can handle any task, you can help. There is no need for background in deep learning, because you can just deal with data. You can create some scripts analyzing data, analyzing your language, share that on Discord with people. All of that is going to be super appreciated. There is no prerequisite other than you. If you want to obviously do those types of analysis, you need to know some programming language like Python. But even just eyeballing the data as a native speaker can be considered is a valid contribution, obviously. Okay, so this is how they compute the lengths, and we also have to include the length, the source factor. We have to see the lengths, and then if that's smaller than the minimum length or bigger than we filter it out, and also for the ratio. So keep calculating the ratio. Okay, so these are some things we need to compute. The length. No worries, Mohammed. Parsec, analyze data, analyze sentence lengths. That's one thing. And then the same thing for target, obviously, and finally, ratio. Oops. Ratio. Okay, let's start from here. Let me just re-trigger the run here because apparently it died again. I'm gonna stop this. And I'm going to re-trigger prepare data again. So let's push through the validate again. This time it's going to be automatically done because we already have everything cached, all 100% exactly. And then let's remove all of the breakpoints except for these ones here. Just hit F5, let it run Okay, we're at 70. We're making progress, guys. We are at 78% here. While that's finishing, let's go to fairsec and let's write our scripts here. So what we want to do is go through different languages and just compute the length histograms. So previously we were analyzing number of sentences. Now we want to analyze the sentence lengths. We can reuse always the same code. I can maybe later refactor this, but for now, or maybe we can just modify it because we are already reading the files. Let's just add some flags of what we want to compute. So here we want to compute number of sentences. Maybe we also want to grab the lengths of the lines. That's going to be super slow, by the way. So we can create some filters. So or maybe call it features. Okay. So if number of sentences in features, then we can compute this. If line lengths in features, we can add our computation here. So that's how I thought doing this. So we'll have to open up this file. File path. File path. And so here we actually want to open it up. Open up the file. And then we want to go through the file for each of the lines. Line split. No, that's not correct because we actually do want to go through the lines, but we don't want to split. We just want to compute the length. Then what does the ratio do? Target to source. Okay, maybe we need to assert here. We need to assert that the lengths here are always 2. Assert that the length of this is always gonna be 2. Expected by text got more or less. Fair enough. I just need to make it an F string. Okay, looking good. Let's see whether this assumption is violated. How is this going? We're progressing, guys. 92% here. Awesome. Okay, let's kick off this run. Let us comment out this and uncomment this. Let's see, what do I have in my launch JSON? For analyze data, currently using filter data. Nope, let's actually use, let's comment out this and let us use this. So the raw data instead of filter data. Raw data, comment out this. And then let's kick it off. Let's see whether this hypothesis here is violated. Features. I didn't pass any features. Let me just pass an empty feature. For now. And then that means we're gonna skip this, but we're gonna hit the assert. So let's just test the assert. Okay. So it can be 0 as well. Yes. Hit F5 again. Looking good. So that's a valid assumption. Let's stop this. And now we can remove this iteration. So that we can compute both the line lengths and ratios. Okay, I'm gonna make a short break just to stretch my legs, and I'll be back in 3 minutes. Let me put a note here, just a short break. Short break, 3 minutes to stretch the legs a bit. See you soon. Coming soon, guys. Let me just stretch my legs and I'll be back. Okay, guys, I'm back. I see that this stage is completed as well. Let's continue. Let's kick it off while we are doing our own analysis of the lengths of sentences. So let me remove this. Build vocab. This one should be fairly quick because we have a pre-trained vocab to hit. So we'll be basically hitting this branch here. We vandalized the code yesterday, so I know this. And then for dedup sharding, this one might be a bit more complex. Might be valuable to just step through it once first. So, okay, let's hit F5. Let's put the next breakpoint for binarization. Here we are. $52 source languages, 82 target. Okay, here we are. We are hitting the, as I said, this else branch. And then here, we're going to hit okay, we are actually first entering the dedup sharding, deduplication and sharding function. Let's see how many shards we have per language direction. Is there any that's bigger than 1? I guess that's my question. Is there any? There are. English, Latin, we have 28 shards there. 6 shards here. Awesome. Let's see what's the max one. 28. So we go through the... Okay, we can step over this. Let's continue. So this was my assumption. Let's see whether it's valid. It is. We only have a single data set per shard because we concatenated all of the data sets per language direction. Eval should be empty. Yes. If it's none, then try this. Should be empty. It is empty. Okay. Number of shards for language direction. So we are now slowly going through different language directions, and we are appending jobs. Number of shards, eval, and train. Okay. And then let's hit F5 and get to here. The total number of jobs is going to be what? 277. Okay, we can now put maybe a breakpoint. Again, we should probably put this to 16, although I'm not sure how this translates to actual usage. Let's go to run. Let's hit F5. Let's see where we end. Okay, so here we are. Let's hit F5 again. Okay. We are in the run method. We grab the shard, the job. Let's see which dataset will we be processing first. ACE to English. Okay, we have the BCP47 codes here. We grab the shard. We're doing this. We can skip this. We go through the training data sets, which should be only a list of one element exactly. And then we go through shards. We construct the output source shard and target shard. We open up those files, which are going to be again where sharded, under sharded, process data, temporary sharded. Just a second. Okay, let's enter the context here as well. Metadata, we don't have it. And we add to the sharded datasets. Hit F5. We open up all of these files. And then we step over line by line, source, target. And if we've already seen it, if we have not seen it, then we write. Fair enough. And then that's it. That's it. We can put a breakpoint here. Let me just see one thing. Once we are done with that. Okay, let's hit F5. Let it run. While it's running, let's go and play with fairsec. Okay, we were here. So we want to let's name this count pairs. We don't need this. We just need to extract this is going to be the first one, and then we want to have this is going to be file 1 and language code 1, and then file 2 language code 2, count pairs. Let's construct the file paths. Same thing for file path 2. Okay. And then we compute okay, and we actually just add 1 here. Or actually leave it at this, because this is the number of language files. So, going through data, grabbing 1 byte text at a time, reading the file paths, counting the lines, in file 1 and file 2. File path 1. We can just do something like this for the language code 1. And then we can do a similar thing for the language code too. Okay, so that's handled. Now let's handle the actual line length logic. Analyzing the line sentence lengths in files, in again file 1 and file 2. Let's open them up and let's count up the lines, the line length. So we open up file path 1. Actually, let's create a simple function here so we can reuse it. Or no, let's just do it like this. So we open up the file, we go through the file, we have source length. Okay. We will need a similar dictionary like this, except that we'll have lists. This might be a bit heavier. Let me think. What do we want to actually compute here? Line length. What do we want to plot? Because we're trying to figure out why did our filtering stage filter out some languages more aggressively than the other ones. So what we want to do is see the distribution of line lengths, because we know how the length filter is set up. It's filtering out anything between, was it 5 characters and 1050 or something like that. Let's see. Let's quickly open up Stopes again. Here is Stopes. Here is the, let me just close down this sharding logic. As you can see, we're progressing. Filtering is here. Example. So 5 and 1050. Okay. So don't forget, we have to load the factor file. That might not make sense if you haven't been following along. Let me explain it quickly. Let me just find it here. Length filter. So we have to have this source factor, length factors. Let's see where that one is loaded. Length factor, length factors, filter direction, length factors. Here it is. Let's open up that file in parsec. If line length is in features, we want to load that file. From Stopes. So let's go to Stopes. Where is that file? Filtering. Filter configs. Length factors. Here it is. So it just tells you how much more verbose a particular language is compared to English. That's computed on the Flores 200 eval dataset. Let me copy that. Let me grab the length factors file path. I'm gonna for now just hard code it in here. Let's read it and let's load. We'll have to import YAML. I'm not sure whether YAML is a third-party package or just standard library. I think it might be third-party. Because of that, we should put it here. I'm just trying to cluster my imports in a neat way there. Okay. So the length needs to be multiplied by a factor. That depends on the language direction. So we can compute let me see. Language direction will be changing every time, so we can just do this. Factor length factor 1 is this. Length factor 2 is this. Exactly. Okay. And now we want to do what? What's the visualization? What's the plot that will provide us the most insight? Let me think for a second. Definitely a histogram. So on the x-axis, we want to have the line length. On the y-axis, how many of those line lengths do we have? And then we can see where the mode of that distribution lies and whether it's between the boundaries 5 and 1500, which is currently set as the default thresholds for filtering. So that's what we want to do. So let's do that. Okay. Let's create a line lengths 1 array, and let's keep on adding those line lengths. Let's just keep on appending them. Append line length there. Just go through the file, keep on appending, keep on appending. And then we repeat the same logic here, line lengths 2, and then with open, everything remains the same. Exactly. Okay. And now what we do is we grab our line lengths default dictionary, and we grab the language code 1 and we extend with line lengths. I'm not sure whether that's gonna fail, but the default dictionary should handle that. In the sense, if the key still does not exist, will it handle gracefully this extend function? Let's see. So here we grab lang code 2 and we extend it with line lengths 2. Okay, looking good. Looking good. Let's see. Will we have any issues with memory here? There is a ton of files, and some of them are literally in the millions. So that means we'll be storing millions of numbers here. Let's see. I don't think this is going to cause us any issues. It might be in the tens or even hundreds of megabytes. I'm not sure. Let's see the number. I guess it depends on the number of sentences, right? So if we compute that first, let's see how many sentences in total we have. We found what? Some. We grab the, for each language direction, how many sentences, we count up the values, and that's the number of sentences, okay? So, and that then depended on that, we can easily compute how many, what's going to be the size of this. And finally, we'll be able to plot the histograms. So let's do this. analyze primary data. Let's put number of sentences here, like this. Just compute the number of sentences. And let's put a breakpoint here. We should be good. Let's kick it off. Let's see how many sentences we have. So we have 722 files apparently. And each of those files has some number of sentences. Let's see what's the cumulative. Let's see what's the final number. Okay, it's 361 because we have what? Because we are computing this logic a bit differently. Pairs. Okay, that means we need to multiply by 2 here to have the right printing logic. Okay, let's see. Number of sentences is almost 300 million. Okay, that means we're gonna store 300 million ints. I assume length is gonna be an integer. That's 4 bytes. $300 million. For each of those sentences, roughly 4 bytes. So this is the amount of bytes we'll be storing. Let's divide it by 1,000 million. Okay, that means we have roughly a gigabyte of data in that dictionary, which is a lot. Eval went through, SK asked. We are still pushing through. We are now progressing here. We are at the stage where we are running deduplication and sharding. Let me just see whether it's stuck, or maybe it looks like it's still running. We're still waiting to hit this breakpoint. I don't see any progress. Everything's still running. Let's let it run a bit more. If it's stuck, we're gonna just re-trigger the job. Okay, guys. So finally, we can now plot the histogram here. For each of the languages. Alternatively, we can focus only on a single language. We can maybe specify languages. And if it's none, we do everything. If it's some particular string, then we focus only on that language. So let's focus only on Spanish. Let's go and focus only on Spanish. So that's SPA Latin, that's the BCP47 code for Spanish. Maybe it can be a list. If it's none, then nothing. Otherwise, let's put in a list there. Okay, and then here we ask one thing. We ask whether one of the languages is among our desired languages, and then we put in the data. Okay, so let's focus on Spanish again. Okay. if language code 1 is in length, compute. And let's guard the next block using a similar logic. Here it is. Okay. So now let's go down there. Let's just put line lengths. Let's put only Spanish, and let's analyze this. Okay. So we'll be loading this data first. Then we'll be going through this logic to compute the number of files. And then we'll be going through here. And finally, again, here we have to put if line lengths, actually not if line lengths, if number of sentences, only then compute, only then store the pickle. Let's see, let's plot the data. So for Spanish, sorry, let's grab let's go through the keys. Let's compute the line lengths. We don't need the log here. These are line lengths for this particular language. It's going to be a bunch of numbers, and then we want to plot a histogram, right? So okay, I think Copilot has done a solid job there. A number of bins, 100. I'm not sure that's gonna be enough because line lengths can oscillate obviously much more. Let me think. Let's put in I think let's put 200. That's gonna be fine. And then the label, and that's it. Okay, guys, moment of truth. Let's go on and compute this. Okay, let's kick it off. I see a lot of people are joining right now. Welcome, welcome. Guys, if you're not familiar with the project or what I'm doing, join the Discord community we have, and in particular the Meta NLLB replication channel. And you can contribute in various ways, even if you're not a programmer or if you're not a machine learning expert. There is still a ton of work we'll be able to do, including you can be a language champion, which means if there is some language which you speak which is not in this table, and even if it is, you can add your name and your social media links, and then we can ping you, and you can help us around various languages. And let me paste this here to the live chat, and in return you'll be credited in the README of the project as somebody who contributed and helped. So just FYI. Okay, let's load the length factors for each of the languages, which tells us how verbose a language is compared to English. Let's now keep on. Okay, we have, for some reason, language code. Interesting. I think the reason we completed immediately is because there is a discrepancy here. Language code here, this guy is returning ISO 639 codes. So we need to map those, or we need to change our code here. Let me think. We can just put, the easiest solution here is go here, and instead of BCP 47, just put ISO 6393, which is 3-letter code. And again, let's rerun this. Let's just first stop this run and let's rerun it. So now we should be hitting, okay, so there is an error now. And here, okay, length factors are expecting BCP 47. So this is not going to be a solution. Instead, let's get big. Let's just map, let's find the mapping into BCP 47, which is here. Here it is, analyze data. Let's import this, and let's grab and map those language codes before indexing. So here is the language code. Let me think. Why not just return BCP 47 directly? Let me just see where this is called, this function. Only in analyze data and define there. And it's also called here, but it's not used apparently. It looks like it's not used. No, actually it is. Actually it is. Okay, I'm not gonna modify this function. Let's go back here. I'm just gonna map this code. Let's just map this code to BCP 47. Same here. And let's hope this now works. Okay, it did work, but again, for some reason, we are not doing anything. English, Latin. Oh, okay. Made a mistake there. A lot of small gotchas. Okay, analyzing. So we read a couple of files that have Spanish, as you can see here. And let us see what's the distribution. We grab the line lengths, of which there is 84,000, and we plot that on a histogram. Let's see, where is the mode of the distribution? It definitely looks like it's around closer to 0 than it is to 1,000. Okay. So it definitely doesn't seem justified that Spanish would get filtered because of line length. We saw before that 30% or something of Spanish data was filtered out during the filtering stage for some reason. Let me just share this plot with people who are following there in Discord. Okay, print screen. Looks like Spanish line lengths are well inside the 5 to 1050 hair length range. The filtering numbers, 38%, not justified by a line length filter. The filtering line numbers not explained. Probably duplicate data. We'll push out the new analysis scripts soon. Okay. Let's see some other languages. We had GRN, French. Those three are the most here. GRN, French, and there is the Hindi as well. Okay, let's try a couple of those languages. Let's just add a couple of those languages. So GRN, I think that's GRN Latin, and then French is certainly Latin, and then Hindi, I'm not sure what's the script. Let's quickly go. If anybody knows, you can tell me in the live chat, but let me go to mappings here. GRN is going to be Latin, French, obviously Latin, and Hindi is going to be Hindi Deva. Okay, Hindi Deva. Let's go back to Persec. Let's go here. So Hindi DEVA. Okay. So let's analyze all of those histograms. Plot and then plot close. So we can close the previous plot before creating a new one. Let's maybe increase the number of bins, and let's add, let's see. What I'm curious about is what are some of the numbers after 1000? Like, what's the cumulative number of sentences after 1000? It's not always easy to see on the plot. Let's rerun this. Okay, we are analyzing the languages that we've picked. Okay, here we are. Let's go to the plotting loop. The first language we are dealing with is Hindi. Here it is. Okay. Something is not okay here. There seems there are some huge outliers which are messing up our plot significantly. Okay, let's just see what's going on. Close. Let's go to the second language. Second language is Spanish Latin. We've seen this one. We've seen Spanish. Let me open it up. Again, here is Spanish. Spanish looks more reasonable. Most of the weight of this distribution is definitely here. I mean, distribution, this is histogram, but you get my point. Next language is GRN, Gujarati or something. I forgot what it stands for. Here it is. Again, well underneath. This is well underneath 1,000. This is like the worst language when it came to filtering. So that means it's probably a bunch of duplicates. And let's go and see French. What's up with French? Okay, looking good. French is looking good as well. Well below 1,000. Okay, so all of these make sense. The only weird one was Hindi. Hindi had some weird outliers. So let's see how we can further analyze this. Let's just focus on Hindi. Let me move all of these here. And let's go back here, and now let me stop this. So what can we do for Hindi? We can go and grab the lengths and see how many of them are bigger. Maybe print like the maximum. Also print average. Okay, and also compute sum of elements who are line lengths bigger than 1,050. If you're bigger than 1,050, we need to know how many of those outliers there are, and then we need to put that into relative perspective. So okay, and then let's just print found that many outliers, and that's this percentage in this language, and just close the bracket. Okay guys, let's rerun Hindi. I know Hindi has a ton of sentences. That's why it's taking a bit longer to compute. So here are the line lengths. The maximum line length is 35,270 characters. That's wild. I'm curious, what's the next biggest element? We could have sorted it and asked for the couple of biggest ones. Average is 90, which makes sense. Outliers, oops, some error here. Okay, I can't do this with line lengths because I assumed line length is gonna be, let's just convert it into NumPy array. Let's convert this into a NumPy array, and then we can do something like this. Will Max work on NumPy arrays? I'm not sure. Let's see. Okay, average 90, sum. Okay, so found 568 outliers, which is again super small percentage. Like there's only 568 sentences which are basically above this threshold. So that means line length filter will not be filtering a lot of sentences. I'm just curious. Let's see. Let's find those sentences. Let's maybe do the following thing. Let's grab the NumPy find k largest elements. So Okay. We can do something like this. Let's find ten biggest elements. Let's find k biggest elements. And let us do what? These are the indices. Okay, let's just print line lengths of indices. Let's see how big those are. And then we actually care about sentences. I want to see what those sentences look like. Somebody who speaks Hindi could help here, for example, because there might be some language rules I'm not familiar with, which are causing some, but like it looks like it's an outlier, so probably not a Hindi specific thing, just, okay, here's some indices. Let's print those values. Okay, so some of the sentences are like 8,000, 9,000, 10,000, 11, 17, 15, 13, 35, 23, 13,000. A lot of very, very, very large, long sentences. Let me ping Amrit. Amrit actually speaks Hindi and he's involved. Let me just print it. Let's go here. Let's plot it. Let me plot the legend. Okay. I just sent this to our server. So now a cool thing would be if we can do what? If we can find those actual sentences. And to do that, we can do the following thing. We can define a line threshold. We can define it the same as before. And then if that length is above the threshold, we can print the actual sentence, right? And the file. Let's also add line count so we can see we can easily see the found a line on the line. With length in file, okay. We can also store this and then analyze it later on, but I think for now this should be good enough. Length 2. Okay. Looking good. Let's see. Let's put some breakpoints here. There is 500 of these lines. Maybe we can increase the threshold. Let's bump up the threshold a bit. Let's bump it up to 7,000. I'm just curious about these bigger outliers. Maybe we can bump it up to 7,000. And let's now rerun this. So there's gonna only be a couple of outliers of that kind. Let's just stop this. Let's hit the lines. Okay, here is the first one. The length. Okay, this is apparently the line. What's the length? Oops, that's a mistake on my side. I forgot to update this to right indices, and here we also don't have I. That's what happens when you duplicate code instead of just reuse stuff. Okay, let's rerun. $7,000 in file. This one, line 2904. So how the lines are, let me just think for a second. I guess the new line is the separating character for these texts. Let's open that file. Let's open train Hindi Deva file. Let me paste it here. Let me copy it and let's find it. Okay, apparently there is a ton of these files and we did not return back the whole path. I'm not sure which one this is, but certainly we can tell that something is off here. It looks like a combination of English and Hindi. I do know that Hindi oftentimes uses, let me just paste this. It's some kind of a weird mix of English and Hindi, even though it's supposed to be pure Hindi. Okay. Anybody has a clue, guys? Anybody speaks Hindi in the stream? Let me see. Okay, we can actually grab. Here it is. So Wikimatrix English Latin to Hindi Deva. Okay, let's go there. Let's go and find our data. By the way, am I using the right one? Okay, both should be the same actually. So let's go to data sets. Let's go to Wikimatrix, which is, I think this is mined data, by the way. Wikimatrix is mined data. So English Latin to Hindi Deva, this one. We're looking at train Hindi Deva, this file. And then, so you can see normally, by the way, how do we show white spaces in VS Code? Display new lines in VS Code. How does one do that? How to show line endings? Render line endings. Okay, let's quickly see whether this works. If not, we're gonna immediately delete it. How does this thing work? So go to view, render white space. Okay. Go to view. I don't see the render option. Terminal, testing extensions. Editor layout, appearance. Render white space is included. Then why don't we see it? Okay. Actually there is some small error that you can barely see. Okay, let's go to line. What was the line of this one? 2900, and it looks like this. US Census Bureau. We can maybe just search for this as well. Let's go here. Let's quickly go here. Okay, here it is. And then apparently it's a long one. Okay, it's indeed a very long line. Let's go to the end. Here is the end. So it ends with this particular string, 11, 22, 4. Analyze data, open this line. Let's see, oops. Let's see where we see the 11, 22, 4. Here it is. So that's the, yeah, that's the sentence. Apparently there are these sentences which are super long. Let's go even further. Let's stop this. Let's basically put 30,000 here. Let me now delete the extension, that we don't really need it. Okay. And let's run this again. Put the breakpoints, hit F5. Okay, here we are. 35,000. That's the only and the longest sentence we have. Hindi translation. Huh. Weird. Just send this to Amrit again. Okay. Okay, but one thing is sure, guys. It's not the length filter that's basically doing this. So again, this is just a bar plot that tells us how much data we filtered out per languages. And we can see Spanish, GRN, I forgot what's the name of the language, French are the 3 top ones here. And then we have here, let me see, FON and ORY. Let's see what's the FON language. What's this FON language? Let's quickly see what's FON. FON is not even found here, so let me just check my notes. Let me just double check my notes on languages. FON. Wait, we never had this one. What's this? I might be, let's see, Ori. Interesting. Let me think for a second. How did we get to analyze the dumps and then go through the languages? Interesting. Okay, we don't even have to tackle those right now, although it would be good. Okay, I think I'm gonna wrap up the stream for now so that we can start on time the next one. Quick lunch break, and then catch you guys after the lunch. We're gonna continue analyzing the data. I'm gonna continue pushing through the stopes here. Let me just see what's happening here. So it's kind of stuck. So let me stop it and let me rerun it. So let's rerun the prepared data. Again, we should pass through the validate step fairly quickly because everything is cached. Also retrieve data. I really hope that we will not be hitting, let me see though. Let's put F5 here and F5, sorry, breakpoint here and breakpoint here. And then, okay, then we are done. Let me just quickly go through this one. Okay, just remove the breakpoint here. It looks like we are making progress, 84%. Okay, while this is running, I'm gonna go grab some lunch, and then guys, catch you in the next stream. SQ, see you later. See you later, guys. I'm gonna leave this running and then continue a bit later. Cheers.